You were a whole person once, laughing, learning, watching everything. You had a favorite blanket, a favorite song someone sang to you. You had a first best friend. You cried for the first time and someone came running. You learned what love felt like before you even had the word for it. You built an entire understanding of the world. In your first 2 years alone, more learning than almost any other period of your life. And you remember none of it, not 1 second. You can access right now. That's called infantile amnesia. Every single human on Earth has it. No exceptions. For decades, scientists had one simple explanation. Baby brains just aren't developed enough to remember. Case closed. For almost 100 years. But here's where it gets weird. Scientists just proved that theory wrong. Babies do form memories. So then, where did your baby memories actually go? Are they gone forever? Or are they still in there? Somewhere. Sigmund Freud was actually the first to name this phenomenon. He called it infantile amnesia back in the early 1900s. His explanation was totally different though, and wrong too. For 100 years, nobody could truly test any of these ideas, because babies can't just tell you what they remember. You need a way to peek inside without asking. Let's start with what scientists used to believe. The hippocampus is your memory-making organ. Old theory said, it's simply not built yet in babies, like trying to save a file with no hard drive installed. No memory center. No memories. Simple. This theory lasted from the early 1900s all the way to recently. Nobody had the technology to check. You can't exactly ask a baby what it remembers, so the theory just sat there, unquestioned. Then modern brain scanners got good enough. That took almost a century of technology to catch up. Scanning a baby's brain is genuinely hard. Babies wiggle. Babies cry. Babies do not sit still. The Yale team had to get creative. They scanned babies while they were naturally alert and calm. This alone took years to perfect. The study was published in the journal Science, one of the most respected science journals in the world. This wasn't a small claim. It was a big deal. It rewrote a chapter of neuroscience textbooks. The specific brain region involved is called the hippocampal formation. It's the same region adults use for making new memories, good enough to scan an actual baby's brain while it's working. And that changed everything. In 2025, a team at Yale ran a groundbreaking study, led by a researcher named Nick Turk-Brown. They put actual babies into an MRI scanner, ages 4 months to 2 years old. They showed the babies pictures, new faces, new objects. Then later, showed the same picture again next to a new one, and watched where the baby's eyes went. Babies looked longer at the familiar picture. That's the tell. That means they remembered it, and the brain scan showed something incredible. The hippocampus was active, right there, encoding, the exact opposite of what the old theory predicted. This kicked in around 12 months old. Even earlier hints showed up as young as 3 months. Babies were quietly making memories the whole time. Nobody knew, because nobody could ask. So wait, if babies make memories, just younger, smaller, still learning its job. Here's another clue that points to a retrieval problem. Young children can sometimes recall things from age 2 or 3, but those same memories fade as they get older. This is called childhood amnesia, a slightly different phase. If the memory was truly deleted, it couldn't fade. It would just be gone. Fading suggests it's still there, just getting harder to reach. That's a big clue supporting the retrieval theory. There's also the neuron replacement idea. Babies grow brand new neurons in the hippocampus at incredible speed. This is great for learning, but maybe rough on old memories. Too many new connections might scramble the old wiring. Like rearranging furniture while the lights are off. Why can't we remember any of it as adults? This is the new mystery scientists are chasing. And there's a leading new theory. It's not a storage problem. It's a retrieval problem. Think of it like a library. The baby memories got written and shelved. But the library card catalog never got built. You can't search for a book with no catalog. The books are still there. You just can't find them anymore. Part of the reason? Language. Adult memories get tagged with words. Baby memories don't have that tag. Without a word tag, the brain struggles to pull it back up. Another reason. The brain is under massive construction. Thousands of new neurons every single day. All that new construction may disrupt the old connections. You might still find the couch. Eventually, somewhere. This research on mice started years before the Yale baby study. Researchers had noticed something odd in young mice. Baby mice forget specific memories much faster than adult mice. This is the exact same pattern seen in human infants, which made scientists suspect the mechanism might be shared. So they built the experiment to test it directly. They trained baby mice to fear a specific box. A few weeks later, the mouse acted completely normal around that box. By every visible measure, the memory was gone. That's when they used the light technique to check, and the fear response came roaring back instantly, proving the memory had been there the entire time, sitting quietly, completely inaccessible through normal means. This is one of the most cited memory experiments of the decade, because it flipped the entire assumption about forgetting, like renovating a library while it's still full of books. The books don't disappear. The paths to them do. Okay, here's where it gets genuinely sci-fi. Scientists tested this exact idea on mice. Baby mice formed a memory, then seemed to forget it. Classic infantile amnesia, just like in humans. But scientists had genetically tagged that exact memory with light-sensitive proteins. This technique is called optogenetics, using light to switch specific neurons on. They shined the light on that exact memory, and the mouse's behavior changed instantly. The forgotten memory came back. It was never actually gone. It was just locked. And the light was the key. This proves the memory trace physically still existed, even though the mouse acted like it had no idea. Right now, researchers are trying non-invasive ways to test this in humans. Things like gentle magnetic stimulation, not lasers in your skull. Early results are mixed, but intriguing. Some people report strange flashes of sensation during these tests, a feeling without a face, a sound without a story. Could that be an echo of a locked memory leaking through? Nobody knows for sure. Yet. This is why memory research is one of neuroscience's hottest fields. Because the implications are enormous. If baby memories can be unlocked, what about other lost memories? Memories lost to injury, to aging, to trauma. Could all of it be sitting there, waiting for a key? We obviously can't shine lasers into human brains, but the mouse experiment changes the whole conversation. If it's true for mice, it might be true for you. So here's the actual sci-fi possibility. Turk Brown himself said this could be radical. Your earliest memories might still exist, right now, inside your head. This very second, your first steps, your first word, the face of whoever held you the most, possibly still sitting in there, waiting for a key that doesn't exist yet. Some pilot studies have hinted at something wild. Toddlers shown secret home videos from their own baby POV. Some seem to recognize it, briefly, but that ability fades fast, usually gone by preschool age, as if the door is slowly closing. That question alone could reshape how we think about memory loss. This tiny question about baby memories might matter for everyone. This whole thing started with a simple question. Why can't I remember being a baby? And it led to one of the strangest frontiers in modern science. You are not missing those years. You're just locked out of them. For now. This window is called childhood amnesia. Most people's first memory is around age 3 or 4. Everything before that, locked in the vault. Scientists are actively working on how to unlock it. This is genuinely one of the most exciting frontiers in neuroscience right now. And maybe, just maybe, someday you'll get to see it again. Your first laugh, your first steps, that face you loved most. Still there. Still yours. Just waiting. Okay, full picture. The old theory said your baby brain was empty. That theory was wrong. Your baby brain was working, encoding, filing, from almost the very beginning. The problem was never storage. It was retrieval. No words to tag the memories with. A brain under constant construction. Paths blocked, books untouched. And in mice, scientists proved the memory can come back. With the right key. So somewhere inside your head, right now, your first laugh, your first steps, the very first time someone said your name and you understood it, might still be sitting there, waiting for science to build the key.